How to estimate the diffusivity of a gas mixture? Here is the question. Calculate the diffusivity of methane to ethane system at 104 degree Fahrenheit and 14.7 psi. Now, the first thing to do is to convert the pressure and the given temperature. So let's start. Solution. One ATM, that is the SI unit for pressure, is equal to 14.7 psi. If you check your conversion table, 1 ATM is equal to 14.7 psi. So to convert the temperature from Fahrenheit to Kelvin, so you make use of this formula. You have temperature in Kelvin equal to degree Fahrenheit minus 32 over 1.8 plus 273. So converting it now, you have temperature equal to, from the question you are given the temperature as 104 degree Fahrenheit. That is 104 minus 32 divided by 1.8 plus 273. So you have 313 Kelvin. In this case, since you have your pressure as 1 ATM, so the suitable correlation or formula for us to use is Slate equation. That is using Slate equation. So Slate equation is used to calculate the diffusivity or to estimate the diffusivity of a gas mixture at pressure of 1 atm, and it is given as diffusivity AB equal to A multiplied by B multiplied by C multiplied by D, all divided by pressure. Where A is given as PCA multiplied by PCB, all raised to the power of 1 over 3. Where PC is the critical pressure and B is given as TCA multiplied by TCB, all raised to the power of 5 over 12, sorry. Where TC is the critical temperature. So heading to C now. C is given as 1 over MA plus 1 over MB, all raised to the power of 1 over 2, where M is the molar mass. So D is given as A to bracket T over square root of TCA dot TCB, all raised to the power of B, where T is the actual temperature. from the question, actual temperature from the question, and A and B are constant. A is given as 2.745 times 10 to the power of minus 4, while B is given as 1.823. So let's say methane is A and ethane is B. So dealing with this table, we have gas, we have critical pressure, critical temperature, and we have molar mass. Let's say A, let's say B. Checking the table overlay, you can see that under the critical property, the critical temperature corresponding to methane is 45.8. So the critical pressure corresponding to methane is 45.8, while the critical pressure corresponding to ethane is 48.2. The critical temperature corresponding to methane is 191.1, and the critical temperature corresponding to ethane is 305.4. The molar mass of methane is 16.04, while molar mass of ethane is 30.07. So the next thing is to calculate our A. From the previous formula, we have A is equal to PCA dot PCB, or is power of 1/3, which is equal to PCA, which is 45.8, multiplied by PCB, which is equal to 48.2, or is power of 1/3. We have 13.021. Calculating for B, which is TCA dot TCB, or is power of 5/12. We have TCA is 191.1 multiplied by TCB, which is 305.4, or is power of 5/12. We have 96.803. The next thing is to calculate C, which is equal to 1/m A plus 1/mB, or is power of 1/2. We have 1/MA is molar mass of methane, which is 16.04, plus 1/MB, which is molar mass of ethane, 30.07, or is power of 1/2, we have 0.309. Next is to calculate D, which is given as A to bracket T over square root of T CA dot T CB dot power of B equal to A is given as 2.745 times 10 power of minus 4 as constant. To bracket T is the actual temperature from the question, which we converted to 313. That's in Kelvin. Divided by square root of TCA, which is 191.1, multiplied by TCB, which is 305.4. Or is power of B, which is given as 1.823 as constant. Calculating this, we have 4.401 times 10 raised to the power of minus 4. Now, the next thing to do is to calculate the diffusivity AB, that is the diffusivity of methane to ethane. Now, we have D, that is diffusivity AB, from the previous formula, A multiplied by B multiplied by C multiplied by D, all divided by P. Mind you, P is the given pressure from the question. So here we have A as 13.021 multiplied by B as 96.803 multiplied by C, which is 0.309 multiplied by D, which is 4.401 times 10 power minus 4, all divided by the actual pressure from the question, which is 1 atm. Here we have the diffusivity AB equal to 0.171 centimeter square per second. So the estimated diffusivity for the gas mixture methane to ethane is equal to 0.171 centimeter square per second. This is the solution